Hi, I'm Miss Hall, and this is Lesson 89, Z-Scores Percentiles. In the previous two lessons, we learned about normal distribution. And in this lesson, we're going to learn about standard normal distribution. The standard normal distribution is the normal distribution with mean 0 and standard deviation 1. The formula below can be used to transform x values from a normal distribution with mean mu and standard deviation sigma into z values having a standard normal distribution. The z value for a particular x value is called the z-score for the x value and is the number of standard deviations the x value lies above or below the mean. So you can see here the z values above the mean are positive. So a z value of 1 is 1 standard deviation above the mean, 2 is 2 standard deviations above the mean, and 3 is 3 standard deviations above the mean. And if you go below the mean, then you have negative z values. The percentages stay the same. So 68% of the data lie within 1 standard deviation above or below. And then we have 95% and so on. So that stays the same. What we've done is we can convert any normal distribution curve into a standard normal distribution curve. And then we'll have these things called z-scores, which will tell us how many standard deviations above or below the mean. For a randomly selected z value from a standard normal distribution, you can use the table below to find the probability that z is less than or equal to a given value. For example, the table shows that the probability of z being less than or equal to negative 0.4 is equal to 0.3446. Okay, let's pause for a minute. So the probability of the data, or your z-score, being less than or equal to negative 0.04, so that's approximately here. And so we want to know in this area under the curve how much of the data is represented here. And we couldn't do this previously. We couldn't find a percent that wasn't 1 standard deviation or 2 or 3 that wasn't related to the 68%, 95%, 99.7. But now that we can convert to a standard normal distribution, we can find the percent of any value. And again, so what we do is we want to know from negative 0.4, and we find where that column and row meets, and it's 0.3446. In other words, 34.46% of the data lies at or below negative 0.4 as the z-score. Example 3. Using a z-score in the standard normal table. A study finds that the weight of infants at birth are normally distributed with a mean of 3,270 grams and a standard deviation of 60 grams. An infant is randomly chosen. What is the probability that the infant weighs 4,170 grams or less? I'm going to start by approaching this problem as we did in the previous lessons. I'm going to sketch the normal distribution curve of this problem. So the mean value is 3270. The standard deviation is 600 grams. So 1 standard deviation above will be 3870. 2 standard deviations will be 4470. And I could keep going above and below. Let me do just a few more. So this is going to be 2670, right? So I'm adding 600 above the mean. I'm adding 600 each time I go a standard deviation above the mean, and I'm subtracting 600 each time I go a standard deviation below the mean. And then we have 2070, and then 1370, and I'm just missing 5070. So what this problem is asking is an infant is randomly chosen. What is the probability that the infant weighs 4,170? So that's somewhere here or below. So I've got to figure out the area under the curve here. And it's between 1 and 2 standard deviations. So I can't just use the 68% doesn't help me here, the 95%, because it's between 1 and 2 standard deviations above the mean. This is why we need this z-value. So let me get this z-score. So the z-score is going to be the x value I'm investigating, which is 4,170, minus the mean score, which is 3,270, all divided by the standard deviation. So this is the formula. When I simplify, I get 1.5, which is reasonable given the graph I sketched. So it was somewhere between 1 and 2 standard deviations. It makes sense that the z-score is 1.5. So now I use the standard normal table, and I'm looking for 1.5. And these meet here, which tells me that the probability, on the front that x, okay, the probability that an infant weighs less than or equal to 4,170 grams is 0.9332, or this is the same as 93.32%.